All right, now we have finished for exercise 1 part A, and I've gone through 5 different gate voltages and then measured the drain source. Well, this is technically the drain voltage because we were having trouble measuring the current with our multimeter because it does output a slight voltage in order to measure. So we're just going to take the voltage and divide it by 1,000 to find the current because that's the resistance that we're using here. So I just measured technically the drain source voltage, and then we're going to divide all these values by 1,000 to find the drain source current. But I have it here, and then I'm supplying our circuit with a drain voltage and a gate voltage here, using the 2 different prongs from our DC power supply. So I've just gone through and I've filled out the chart for all the different values that we needed, and once again we're going to divide by 1,000 to find our current.
Hello, this is Braden Black, and for exercise 1 part B, we have a PMOS transistor. So we set it up the same way as part A for this exercise, except flipping orientations to match the PMOS. And in the multisim, we get these different curves using a 1 kilo ohm resistor. And we have it set up here the same way as on multisim. And we'll measure the drain source current. And we do get matching results as the VDS increases. The IDS also increases linearly, just as multisim. And we take all these values in the current, put them in these tables as we sweep VGS from 0 to 5, and then VDS from 0 to 10 in all cases.
This is Thomas Young with student ID number 11357159-1, doing lab 2 exercise 2. You can see my setup here, a bit of a jumbled mess. These are the AND transistors. You can see them plugged in one after another. These are the OR transistors. You can see them somewhat largely aligned with their gate sources separated, and then plugged into ground with the pull down resistors to make sure that current is at a safe range so that nothing goes poof. We are plugged into the 5 amp channel. Now we're going to run our 4 logic states. So this is on. So this is 0, 0. Now we're doing 0, 1. You can see our OR LED is turned on. Now we'll do 1, 0. And you can see our OR LED is on again. And now we're going to do 1, 1. And you can see both the OR and LED are on.
This is Carter Hurst on exercise 3, part 2. 113-605-311. There's my multisim. So I'm trying to find the 50 UA through the base IB50 UA. I got it to 49.645, pretty close in the microamps, which is connected through this resistor. It's 100 ohm in series to the base. Here we have base to emitter.
It is.
Doing surgery on people that just got shot.
Base to emitter.
High-ranking soldiers who also have their
Is that many?
experience in surgery.
Base to collector.
They're not the youngest. They're out risking their lives. Working on hospitals.
440.
Now I have to take a video.
Beautiful.
And I'll do this because it's wrong.
That's probably another brain on But think about it. That's a good buy. One email for one recruiter.
Emitter to collector is 1.1.